Now learning physics will be great fun with a physics teacher. A solution to all problems in physics.
The physics teacher.
We have two parallel plate capacitors, each of capacity 2 microfarad. Each are connected in parallel across a battery of EMF 30 volt as shown in the figure. After charging, the battery is disconnected and the space between the plates of any one of the two capacitors is filled with a uniform dielectric with dielectric constant 5. Find the final charge on the capacitor with dielectric is. So out of the given choices we have to find which one is the correct one. So here we have the arrangement in which we have two equal capacitors, each of capacitance 2 microfarad connected with this 30 volt battery. So the charge on each capacitor say is Q each, because both the capacitors are of equal capacity. So the total charge supplied by this battery is 2Q. So 2Q, the charge supplied by the battery, is equal to the equivalent capacitance of the system, that is 2C, into the potential drop across the system, so that is V. So the total charge supplied by the battery is 2 into 2 microfarad into 30 volt. So this gives us 120 microcoulomb. So this is the charge supplied by the battery. Now next what he is saying, that we have to disconnect the battery. We have to disconnect the battery, and after disconnecting from the battery we have to insert a dielectric slab between any one of the capacitors. So let us insert dielectric slab between this capacitor. So dielectric constant as given is 5. Now due to the insertion of this dielectric slab between the plates, the capacity of this capacitor will change. Suppose the new capacity becomes C dash, but its capacity will not change. Capacity of this capacitor remains same and capacity of this capacitor will change. Now the new capacity will become 5 times the initial capacitance. Now due to the insertion of the dielectric slab between the plates of this capacitor, the potential drop across the plates of this capacitor will become different than the potential drop between this capacitor. Now due to this difference in potential, the charge between them will flow, and this procedure will go on unless the potential drop across the plates of both the capacitors will become same, but the total charge, that is 120 microcoulomb, will remain same, means the sum of the charge on both the capacitors will remain 120 microcoulomb. So suppose the charge on this capacitor is Q1, clear, and let the charge on this capacitor is say Q2, clear. Now the sum of the charges Q1 plus Q2, so that is equal to 120 microcoulomb, and this final charge which both these capacitors has achieved is due to the situation that the final potential drop across both the capacitors is same. So using this phenomena we can say that the common potential V is equal to Q2 by C dash, that is 5C, is equal to Q1 divided by C. So from here we can write that Q1 is equal to Q2 by 5. So using this result here we can write Q2 by 5 plus Q2, 120 microcoulomb. So from here we can write Q2, that we have to calculate the charge on the plates of the capacitor in which we have inserted the dielectric slab. So this comes out to be 100 microcoulomb, clear. So the correct option is C.